Alright, so now we're just going to do a quick linear function. Make sure we remember how to do this. So we're going to take this f of x equal to negative 2x plus 5. So you should be able to graph, just run through slope and intercept. So remember, when it's in this form, it's nice because we're given slope then to be negative 2 and our y-intercept to be 0, 5. Okay, so you start by plotting the point, 0, 5. And then you move according to slope. Remember, slope is rise over run, so since it's an integer, we can put it over 1. So we go down to right 1 a couple times, and then we should be able to draw the line. Should be fairly familiar to you. Also keep in mind, if you were asked, you could find 2 points. Because it's given in function form, I could just say, well, what's f of 0? That's negative 2 times 0 plus 5, which is 0 plus 5, which is 5. So remember, that gives you the point 0, 5, which is the y-intercept. And then maybe I'll plug in f of 2. So it's negative 2 times 2 plus 5, or negative 4 plus 5, or 1. So again, if f of 2 is 1, that gives you the point 2, 1. If you plotted those 2 points, again, you'd get the same line. Okay. Part B is asking for the intercepts. Okay. Again, intercepts are where they cross the x and y axis. So x-intercept is where any graph, in this case we're looking at a line, but x-intercept is where the graph crosses the x-axis. So we can see that it's going to be about right here for ours. Okay. What do we know when we're looking for an x-intercept? We know the y value will be 0. The only way you wind up on the x-axis is if the y value is 0. Okay, so to find our x-intercepts, we know that the y, or the output, should be 0. So we're going to take our function and set it equal to 0 and solve. Okay, so that's just a quick subtraction and divide. So we get 5 halves, or 2.5. Which seems to match our graph. So our x-intercept is 2.5, or 5 halves, 0. For part 2, here for the y-intercept, again, you want to know where your graph crosses the y-axis, which again, we can see. We already had that at 0, 5. Okay, but in general, if you want to know where any graph crosses the y-axis, you know the x value is 0. Okay. So that means for a function, we have to plug in 0. So if we plug in 0 into our function, we clearly get 5, and our y-intercept becomes 0, 5. Okay. All right, and then the last part here says find the zeros. Again, this is a very important question for us as we do other graphs. It's sort of an obvious question here for linears. But in general, finding the zeros, you want the outputs to be 0. We're not plugging in 0, we want the function to be 0. So whenever we're looking for the zeros of a function, we set the function equal to 0. So again, in our case, it's a nice quick linear equation to solve, which we already did. And we got 5 halves. Okay, so the zeros, there's only one here, is at x equal to 5 halves. All right, just one quick review here, because there are a couple special cases with lines, the horizontal and vertical lines. Horizontal lines, right, they go across, okay? They always look like f of x equal to a constant. Okay, so I'm just going to take an example. Right, f of x equal to 2, or sometimes, right, it'll just be written as y equal to 2. Okay, so that's the graph up here, 2 units. Okay, it's just a horizontal line. Every point along the line would be negative 5, 2, 1, negative 1, 2, 0, 2, and so on. Okay, it has slope 0. Okay, it has a nice y-intercept here at 0, 2. Okay, so again, there's nothing unusual about that. It's a perfectly reasonable function. Okay. Vertical lines, on the other hand, remember, are not functions. Okay. So again, I'm just going to take an example. If it's a vertical line, it's stuck at an x value. Okay, so again, I'll take x equal to 3. Okay. So if I want to graph this, I have to go out to x equal to 3 and then just draw that vertical line. Again, when you're looking at the points along this line, it would be 3 comma negative 3, 3 comma 0, 3 comma 2, and so on. Okay, these are not functions. They just take the form x equal to a constant.